they are still area. So we need to still remember our area formula. So I'll give you guys a chance to either take a screenshot or take out whatever paper or whatever textbook you have with the area formulas on them. We're going to need them still. All right. So let's start with this question. This question is on a composite shape. We are going to try and calculate the surface area of this composite shape. But we've got to read the information that we've been given. If you tried this question already, then it should be quite easy for you because I did give it as homework, but I know that some of us are quite busy with other things. So we're going to have a look at it now. All right, let's start by reading what they've told us in this question. The question says, a closed hollow prism made of sheet metal is shown. Calculate the external surface area. All right, so there's a very important part that we need to look at over here. All right, first thing is that it's closed, which means the top is not open, the bottom is not open. Right, very, very important for us to know that. That means everywhere has been closed up, which means the surface on every side is there. But it also says it's hollow, which is also very important to consider. Let me ask this question. What two 3D shapes is this particular composite shape made of? What two shapes do we have here actually? The bottom one is a tri. Good, that's it, Abu, good. The bottom one is a rectangular prism. Rectangular prism. And the top one is a triangular prism. Triangular prism, right? So now, I know that if I were to calculate for my rectangular prism, I can just draw one very quickly over here. Right. If I were to calculate for my rectangular prism, what I would do is I would take the front face. I would say the front and the back are the same. So I would take the area of the front times 2. And then I would go to the left-hand side. And I know that the left-hand side is exactly like the right-hand side. So we'll take the area of the left-hand side times 2. And then I would take the top. And I know that the top looks exactly like the bottom. So I would take the area of the top times 2. Thumbs up. Are we all in agreement? Yes? Yes? And Abu, you are spot on. Now we know that this thing is hollow. We know that this thing is hollow. So there's something sitting on top of it. That means there won't be a top part for me to calculate for, because it's open on the inside. So when we get to the calculating the area of the top and the bottom, we don't need to times by 2. We are only going to calculate the area of the bottom because the top is not there. It has something sitting on it and it's hollow on the inside, right? Same for my triangular prism. I know that if I were to draw my triangular prism, let me see how good my drawing skills are. Triangular prism, right. I know that my triangular prism is going to be made of the triangle here, the triangle there, and then I would have the rectangle at the back. I would also have the rectangle on the front, on the top here, and then I would have the rectangle at the bottom. But because this thing is hollow, there's no need for me to calculate for the rectangle at the bottom. I just want to make sure everybody's okay with this idea. Yes? Are we all okay? Thumbs up. Okay, lovely. So we're only looking at the shapes of my rectangular prism and my triangular prism on the top and on the bottom, not in the middle where they don't actually close up. All right, let's go ahead and look at our calculation. So we want to calculate for the total surface area. All right, so I'm going to break it up into, I'm going to say the total surface area is equal to the surface area of my rectangular prism plus the surface area of my triangular prism. Okay, let's start with the rectangular prism. The surface area of the rectangular prism is equal to, okay, let's start with the front. I know that the front is there. We know that the front is there. And we know that the back is there. The back is also there. So we can calculate the front times 2. That's easy enough. Okay, but remember what ma'am said about every single dimension drawn in symmetry going around my shape, So if this is 5.13 meters, that is also 5.13 meters. That is also 5.13 meters. Okay, all the way around. And if this over here is 2.79 meters, that means this over here is also 2.79 meters. This side over here is also 2.79 meters. That back part over there is also 2.79 meters because we go around. Right. Now, if I come to 2.12, okay, normally I would go all the way around the shape, but I can't because it's hollow in the middle. But I do know that this side is 2.12. That side over there will also be 2.12 meters. And I know that if I go up, that part over there would also be 2.12 meters, but I don't need that part. It doesn't really help me with much. Okay, because the top part doesn't really need any dimensions. Okay, so let's start with the area of the front. I know the area of the front will be times 2. I know that the area of the left-hand side is going to be the same as the area of the right-hand side. So we can take plus the area of the left-hand side times 2 plus the area of the bottom. Normally, I would say the area of the top times 2, but we don't have a top. We only have a bottom. So area of the bottom. All right, let me see. Thumbs up. Who needs my help in calculating for the surface area of our rectangular prism? Thumbs up if you can do it on your own. Let's rather say that. Thumbs up. Can you calculate for this on your own? Amazing. I'm going to give everybody 4 minutes. 4 minutes. Okay. Pop an emoji on the screen when you're ready. All right, are we ready, peeps? Can we look at the answer? Okay, let's do it. Let's do it. All right. Okay, surface area of the rectangle. The area of the front is going to be, I'm going to just open big brackets, 5.13 times 2.79 times 2 plus The area of the left-hand side is going to be 2,79 times 2,12 times 2 plus the area of the bottom just once, and that's going to be 5,13 times 2,12. Right. And we just put all of that together exactly the way that we're looking at it. Anybody got an answer for me? $51.33 meters squared. Amazing. Oh, sorry. I don't know what I did there. Let's have that a little bit smaller. Okay, 51.33 meters squared. Amazing. All right, that's only half the battle, guys. We now have to go look at the surface area of our triangular prism. Now, this one is a little bit more complicated. Okay, I don't want us to think it's just cut and dried. Okay, so I know that I'm going to get that triangle and that triangle over there. And I can calculate for the area of my triangle, no problem. No problem, right? I know that the formula for the area of a triangle is just area is equal to half base times the perpendicular height. The perpendicular height, which is nice, we have the fact that this is a perpendicular triangle. So I know that to find my perpendicular height, I'm just going to take 4,75 minus 2,79. Are we all in agreement there? Yes. Good. Thank you, Abu. The answer that we get is going to be 1,96. Oh, 96. Okay, I'm clicking things. 1,96 meters. All right. Now, I can then calculate for the area of my two triangles because I know that my base is just also 2,12. Right. Now, if I want to calculate for the area of the rectangle at the back, remember, we don't have to do the rectangle at the bottom. I can do the rectangle at the back. That's easy enough. That's just going to be my length, which is 5,13, multiplied by my breadth, which is 1,96. Now, the problem is going to come when we have to calculate the area of this rectangle on the top, this one on the top. Okay. I know the length of this rectangle. I do. The thing that's missing is this side. I'm missing the breadth, right? And I'm not going to be able to see it anyway. They haven't given that to me. So what I need to do, just like Abu suggests, is I'm going to have to calculate using Pythag. I'm going to have to use Pythagoras because I've got a right-angled triangle, right? This side, the side that I'm looking for, let me do that in purple. This side that I'm looking for is attached to my right-angled triangle. It's attached to my right-angled triangle. And I know that side. I know that side. So I can use those two sides and Pythagoras to calculate for the hypotenuse of those two. So let's start with that calculation. So I'm going to go AC squared is going to equal to 1, actually, let's just go all the way. AC is equal to the square root of 1,96 squared plus 2,12 squared. Before I move on, does everybody understand why ma'am has written the formula like that? Thumbs up. Are we all okay with this? Okay, I'm just maximizing the amount of time that we need to not have to sit here and calculate forever and ever. So we can finish quite quickly calculating for this. All right, and the answer we will get for AC is 2,89 meters. All right, so AC is equal to 2,89. So that side over there is 2,89 meters. All right, and that sets us off. We can calculate for the area of the triangular prism, the surface area of the triangular prism. I know that that's going to be the area of my two triangles times 2, right? This triangle and the one at the back, triangles times 2, plus the area of the rectangle at the back. Sorry, let me just say the area of the back, it's a rectangle, we know that, plus the area of the rectangle on the top. Okay, let's put all of those numbers together. So surface area is going to equal to my triangles is going to be half of my base, so half of 2,12 times 1,96 times 2 plus the area of the back. I know that the length of the back is 5,13 and the breadth is 1,96. 5,13 times 1,96 plus the area of the top. I now have my length, still 5,13. 5,13 times the new breadth that I've just found using Pythag, 2,89. All right, and we just punch that into a calculator and we get an answer. Who's got an answer for me? 29,85 meters squared. All right, 29,85 meters squared. And now because we know that it's the total surface area, we just need to take this surface area, the surface area of my rectangular prism, plus the surface area of my triangular prism and add them together. So TSA equals 51,33 plus 29,85. And that will give us 0.03. I forgot. 0.03. 0.03. Okay. 0.03. 0.03 will give us 7980,36. 80,36 meters squared. All right. Are we happy? 80,37. 29,04. All right. I can change that. 0.04. Therefore, this becomes 80,37. There we go. All good. Lovely. It's okay, Abu. It happens to the best of us. All right. Okay. Let's get into some tough stuff. How about that? Yes. Are we ready? Sorry, Gift. Sorry. Okay. Let's look at other 3D shapes, because the 3D shapes we've been looking at so far have been in perfect symmetry. A rectangular prism has the same front, back, left, right, top, bottom. Even my triangles have had triangle, triangle, triangle times 2. My cylinders have had circle, circle times 2. So, oh, excuse me, guys, I've got the hiccups. Let me just quickly take a swig of water. All right, let's look at the area of a sphere, a right pyramid, and a right cone. Now, for now, I want us to just take a screenshot of the area of the surface area of a sphere. Oh, I can zoom out. Sure, Sanela, no worries. Okay, there we go. Did that help? Please tell me if that helped. Oh, zoom out or zoom in? Oh, guys, English is not my mother tongue, hey? Did I do the right thing, Sanele? Was I supposed to do the opposite thing? Oh, for the previous work. Oh, sorry, madam, sorry. Okay, if I zoom out, it's not going to be able to be seen. So I'm going to give you about 30, no, not 30 seconds, 10 seconds to write down what you need. And whatever you don't catch, you and I can chat about at the end of the lesson. Okay, very quickly, very, very quickly. Ten seconds. Okay, she's done. See, in less than 10 seconds even. All right. Okay. We've all taken the screenshot of the area, surface area of a sphere. We're going to skip right pyramid for now. I want us to go and take the formula, I'm sorry, the equation of the surface area of a right cone. Please just either write these down or take a screenshot. We're going to talk about them in a little bit more detail just now. Ooh, guys, it's storming so hard where I am right now. All right, okay. Then we're going to take a screenshot, or we're going to write down the formula for the surface area of a right pyramid. Now, look at it. Look at it. It's a little bit, it's a bit weird looking. And the reason why I wanted to do this last is because I want to explain what all of it means in a little bit more detail. All right, give me a thumbs up once you've had a chance to write it down. Okay, amazing. You guys are super fast. A little bit, a lot. I'm committing crimes. I am not committing crimes. I'm just... Ma'am, is it not 3 pi to the power of 2? Not that I'm aware of, Larato. Let me just confirm. Hold on, let me see. Let's see. No, my darling, it's 4. It's 4. Yeah, I'm correct. It's 4. Okay. Not 3 pi, 4, my darling. Oh, I see I see it there. Okay. All right. Okay. Let's quickly talk about a right pyramid. Okay. But let's break it down into a little bit, into its pieces. So if I gave you guys a triangle, a normal triangle, just a normal triangle, and I said that we're going to calculate the area of this triangle, you are going to say to me, if this was the base, let's say, for instance, we decided that this side was the base over here. In order for me to calculate for the area of this triangle, I know that area is equal to half times the base times the height. Now, this height that we speak of is not just any old height. The height that we speak of is specifically the perpendicular height. So the height from there to there. All right. So when we look at the perpendicular height, it would need to come from the apex straight down so that we can create that perpendicularity over there. All right. So when we are talking about the height of a triangle, it's the perpendicular height, like that. Likewise, if I had to calculate for the area of my triangle and I decided that this over here was my base, the perpendicular height would have to come from the apex over there, right? Going in that direction. There. That's what I would have to do. Right. Now comes the problem. The problem in that a pyramid is not a 2D shape. A pyramid is a 3D shape. So let's say, for instance, we have a square-based pyramid. Okay, hopefully I can draw it and do it justice. Did I do something funky here? Why does this thing not go away? Okay, all right. Okay, so if I were to draw a square-based pyramid, I'm sorry, guys, I tried. Really, I did. I swear I tried. I did. No judgment. I really tried. Okay. I know now that if I have a pyramid, my apex will be over there. And my apex... Oh, okay. You know what? Actually, let's try again. Let's just try again. Because, no, this is not the one. Okay, let me draw. Okay, I will figure it out, guys. I don't know what life is this, but here we are. Here we are. Hi, oh la la. Okay, there we go. Square-based pyramid. Right, there's my apex. I know that I can draw. I'm gonna have to draw a line from my apex to each of the vertices of my bottom shape, of my square. All right, that's what everything is going to look like. Now, if I had to calculate, yeah, I know, guys, I know. If I now had to calculate for the area of each of these shapes, I'm going to have a problem in that I'm going to need the perpendicular height from my surface, from the top, right? From the top of my base. Okay, from the top of my apex. So I know that for this triangle over here, this is going to be my base. And my perpendicular height will have to come from here, going in that direction. There. So if you look very closely, that is not a perpendicular height in this direction, right? In the 3D part of it, that's not a perpendicular height. In the 3D shape, it's a slant height. Yes? Thumbs up. Is everybody understanding what ma'am means? It's not perpendicular. It's not coming straight down. It's going slant down the side of the pyramid. Right. And this will happen everywhere around my shape. It will happen on this front one as well. I know that for this triangle, which will look exactly like that one, by the way, because it's a square and it's a right pyramid. So this will also be my base, and my perpendicular height will have to be the slant height one over here. Now, the problem is perpendicular height and slant height, two completely different things, right? Slant height kind of sits like this. So what we're going to have to do is we're going to have to find the perpendicular height from my apex straight down, smack dab in the middle of my base shape. The base right at the bottom, the shape right at the bottom, right? And then I need to create a perpendicular shape like that. Now, if we look very closely, that shape inside there, what kind of shape is that? It's a triangle, but what kind of triangle? Yes, Abu. Good. It's not just a triangle. It's a right-angled triangle. Do we see it? It's right-angled. And my slant height is also included. It's included. So I'm going to have the height from the apex on the inside. Then I'm going to, now if this thing hits smack dab in the middle of the shape in the middle, that's going to be this, from the distance from here to here is going to be the same as the distance from there to there. So it's going to be half of my base. It's going to be half of my base, right? So this side over here is going to be half of my base, right angle, and the slant height is going to be that side there. Oof. Mind blown, mind blown. All right. Yeah, listen. Listen, I try, Narisha. I do what I can. All right. I just need to check. I know it's like a really, really mind-boggling concept, but do we understand what ma'am has just done? Yes? Are we okay with what ma'am has just done? Lovely. It's quite important that we know this. All right. But that's not why we're doing this. We're not doing this to calculate for just the area of the triangle. Remember, we're calculating for the surface area. Now, my right pyramid is made up of, let me just say, total surface area. My square-based pyramid is going to have the square at the bottom, plus this triangle and this triangle. and then we're going to have that triangle, and we're going to have that triangle. So we're going to have the area of the square plus the triangles times 4. Yes, thumbs up. Yes, because it's a right pyramid, so all the 4 triangles that meet up will be exactly the same. But this is for a square-based pyramid. Let's go have a look at a triangular-based pyramid. Okay, what do we note? We note here that our base shape, the base shape at the bottom, is going to be a triangle, right? So if I want to calculate for the total surface area, I need to calculate for the area of the base triangle plus the 3 triangles that it touches. So the triangle right in front of us, the triangle on this side, and the triangle on that side. So that's going to be the triangles, or let's say the slant triangles, the slant, the slat, slant triangles times 3. Because if you look at my base shape over here, it only has 3 sides. So it's only going to have 3 triangles coming up. All right. It's a bit of a, whew. Sure, no problem. No problem, Tidimalo. Here we go. There's the drawing. Okay, let me know when you're ready. Lovely. Okay, let's do some questions, guys. Let's do some questions. All right. All right. This one says, find the surface area of the following shapes. Shape number 1A, a sphere with a radius of 2 centimeters. Guys, thumbs down, thumbs up. Can you do this on your own? No? Tidimalo's like, no. But the reason why Tidimalo's saying no is because Tidimalo forgot that all we need to do for this question is use the formula. Let's go back. Let's go back. What is the formula for the surface area of a sphere? 4 times pi times the radius squared. Tidimalo, I'm telling you, you don't need me. I can tell you for a fact, for free, that you don't need me. Okay. But we need to write the formulas down. Let's write it down. Okay, surface area of a sphere. There it is. Okay, let's go back to the question. Okay, right. The surface area of a sphere is 4 times pi times the radius squared. So give me an answer correct to 2 decimal places, please, grade 10s. Okay, thanks, Abu. I mean, it's 16 pi, but correct to 2 decimal places, please. Thank you so much, Theo. That's it. 50. Where did 501 come from? Ah, there we go. Okay, yeah, that makes a lot more sense. That makes a lot more sense, right? So I know that my surface area is going to be 4 pi times 2 squared, which is just 50, comma, 265, which would then be, comma, 27 centimeters squared. Easy, easy things. Very, very easy. All right, now let's read. This one is going to take quite a bit of reading. And the only way we're going to be able to figure it out exactly is we need to draw it. All right, we're going to need to draw it. Right, it says here, we've got a right square pyramid. personally, I would have preferred if they had said a right square-based. I need it to be square-based so that I know that the shape on the bottom is a square. Okay, the base shape is a square. All right. Oh, no, not this pen now. Okay, so it says here, the square base pyramid with a length of one side of the square being 4 centimeters, and the height from the base to the apex, which is the very top of my pyramid, is 5 centimeters. Now, we're going to have to draw this in order for us to understand exactly what's happening here. Okay, so I know I'm going to have a square as my base. Okay, there we go. And then I'm going to have an apex. I can do that. Do that. I think I can redraw this one a little bit better. I can do it. There we go. Oh, this one is perfection. There we go. All right. So what we know so far from what we've been told, okay, is that this over here, 4 centimeters, 4 centimeters. At the back there, that will also be 4 centimeters, and that will be 4 centimeters. But it doesn't actually matter because we know that because this is a square base pyramid, if I can calculate for the area of one of the triangles on the side, that's going to be the same as all the other ones. So I can just calculate for one of those triangles and multiply that by 4. Everybody okay with that? Thumbs up? Yes? We're only going to focus on the one triangle because if we get the answer for that one, we can just multiply it by 4 and that will be for everything. All right, lovely. What we've also been told is that the height from the apex coming down, the height there is 5 centimeters, right? And now I know that if I want to calculate for the area of my triangles, I'm going to need my slant height. I'm just going to name it S so that we don't confuse it for H. I'm going to need my slant height. All right. So I know from here, I can draw a straight line like that and draw a right-angled triangle, right? So what I'm then going to do is I'm going to take this triangle on the inside, that one, and I'm going to extract it. I'm going to kind of pull it out so that we can see it better. And I know that it's going to be a right-angled triangle. I know that this side over here is 5 centimeters. That's the side from the apex. What is the distance from there to there, grade 10s? What is this distance over there? How much is that distance? It's 2 centimeters. We're all good with that because it cuts the shape right down the middle. Right, exactly. So I know that this side over here, 2 centimeters. Will I then be able to calculate for the slant height? Yes, I will. I'm just going to use Python. Right. Now, I'm going to remind you guys, the total surface area is first going to be the area of my square, the area of the square at the bottom, plus the area of the slant height triangles, the slant triangles, but there's 4 of them, times 4. Thumbs up. Can I leave you guys to your own devices from here? Will we be able to answer this question? Gift says no. Everybody else? Everybody else is okay. All right. So here's what I'm going to do, Gift. I'm going to give everybody a 2-minute head start. Okay? Let's give everybody 2 minutes. And then once everybody is in the question, then you and I can start looking at the answer. How does that sound? Yes? Just so we don't give them the answer because they want to try it. Does that sound okay? Amazing. All right. 2 minutes, guys. Let's make it a minute and a half. Come, let's move. Abu's already done. Oh, Abu. Give other children a chance. All right, sirs, remember, only maths in the chat today. All right, Gift, are you ready? Can we get started? I'm sure everybody's far now. All right, let's have a look. Okay, so we first want the area of a square. Area of a square is easy. All the sides are the same. So that's just going to be side squared, right? And we know what the side of the square is. It's 4, right? So the area of the square is just going to be 4 squared plus, now before we can calculate the area of our triangle, remember the area of a triangle is half base times perpendicular height. We first need to go and find the height because this is the height that we want. The height is that, which is this thing that we need to put there. Okay, Gift, what are we going to use to find this perpendicular height here? Which formula can we use to do that? It's already in a right angle triangle. It's not a trick question. Good. We can use Pythag. All right, let's go ahead. And we're calculating for the long side. So we're just going to say that our height is equal to the square root of 5 squared plus 2 squared. And just give me an answer to 2 decimal places, please. Just to 2 decimal places. $10.77? Ooh, I don't know about 10.77. Okay, I do agree with 5.39. Yes, 5.39, because that's just the square root of 29, which is indeed, come on, pen, come to the party, 5.39, right? So I know that the perpendicular height of my triangle is 5.39. So I can then open up here, half times the base. My base of my triangle is 4 centimeters times the perpendicular height, which is now 5.39 we've established. And all of this times 4. Times 4. Okay. Oh, why did I close that? All right. And we just punch this into our calculator exactly the way that we are seeing it. Okay. All right. So I know 4 squared is just 16. So I'm going to get 16 plus 4 times 4, that's 16. Half of 16 is 8. So I'm just going to get 8 times 5.39. 8 times 5.39, which is equal to 43.12. Ooh, and my pen, my stylus is just not doing the things today. 43.12. That added together is going to give us indeed 59.12 centimeters squared. All right. Grade 10s, how did that feel? Thumbs up, thumbs down. It's okay. I think it's okay. As long as we know what we're doing, I think it's okay. All right. And it's all about logic. Guys, if we think about everything that ma'am has just shown you here, most of it should be logical for us. It is kind of mind-blowing, I'll give you that. Yes, and that's very true. Who included shapes in math? It was the Romans, because in order for them to build sound buildings, they needed math more than anything else. Yeah, Kulani, I agree. The process is taxing, but it's quite important that we get it right. Yes, they did. Actually, There's a case for something different, Narisha, and I'll let you know at the end of the lesson, but we'll see. All right, here's your next one. The next one says, a right cone with a radius of 55 millimeters and a height of 70 millimeters. Let's just remind ourselves again before we get into this. The formula for a right cone, the surface area of a right cone, is pi r squared times pi r s. And this s over here is also the what? It's the slant height. It's the slant height. Look at it. So there's still some work to be done here. Okay, so again, let's get to drawing, grade 10s. Okay, I know that my base shape is a circle, which is easy. And then I'm going to get a apex, and the apex will go like that. Okay, there we go. And now they're saying the right cone has a radius of 55 millimeters. So from the middle of my circle to the circumference, that is 55 millimeters. And from the height, from my apex coming down like that, is going to be 70 millimeters. All right. So when we want to calculate for the surface area, we're just going to take the area of the circle, which is pi r squared plus pi times the radius times the slant height. That's what the formula says, right? Let's go have a look at the formula again. There it is, pi r squared times pi radius slant height. Okay, so again, we can take this part over here. We can take this part because we need to calculate the slant height, and we can extract it. We can take it out and we can draw it as a right angled triangle. This side over here is 70. This side over here is 55. And we now need to find the slant height. Find the slant height for me, please, grade 10s. Yes, V, I will go back in just a little bit. Can you give me, I see here that you're like, can I see the answer for A? I'll move back up once we're done here. Is that okay? All right, amazing. Thank you so much, Princess and Sanele. Lovely. We now know that our slant height, we can say slant equals the square root of 70 squared, not 70 degrees, 70 squared plus 55 squared. It's because I was doing trigonometry with my grade 9s today that I've got degrees stuck in my head. Okay, equals 89,02. Okay. 89,02. And then the rest is just us punching things into the calculator. All right. So total surface area. Total surface area, I should have written TSA here, is equal to pi times 55 squared plus pi times 55 times our slant height, which is 89,02. Please give me an answer, grade 10s, correct to 2 decimal places. Oh, yes. Oh, no. No, we are not doing trig in grade 9. It's just that the school that I teach at, we do trig in grade 9. That's it, Abu. That's it. 24,884,87. All right. Okay, 24,884,87. 97 or 87, peeps? Is it 97 or 87? 87. Okay. 87. I think maybe it was just a typo because Sanela, I know you got this. But remember, the reason why it's so big is because this is in millimeters squared. All right. Okay, that's the end of the lesson, guys. That's the end of it. Okay, I hope that we learned some very, very valuable lessons today